Thanks everybody for joining us for the second installment of the 2024-25 edition of the joint Harvard Kennedy School Northeastern University Misinformation Speaker Series. Before I introduce today's speaker, I just want to give a plug for the last two events that we're going to host this semester. On December 5th, we have Saren Budak from the University of Michigan, who will be speaking. It'll be a hybrid session in person at the Kennedy School in Starr Auditorium, but also on Zoom, and that'll be at noon on the 5th. And then on December 18th, we have Vish Viswanath from the Harvard School of Public Health, and he'll be speaking via Zoom. Possibly hybrid, we're still looking into that, but that will be hosted by Northeastern University at 10 a.m. Okay, so that brings me to today. We are really fortunate to have Arvind Narayanan here to speak to us. He's a professor of computer science at Princeton University and director of the Center for Information Technology Policy. He is co-author of the book AI Snake Oil, and also author of a newsletter with the same name, with apparently about 40,000 subscribers. He previously co-authored two widely used computer science textbooks, Bitcoin and Cryptocurrency Technologies, and Fairness in Machine Learning. Narayanan also led the Princeton Web Transparency and Accountability Project to uncover how companies collect and use our personal information. He was one of Time's inaugural list of the 100 most influential people in AI, and is a recipient of the Presidential Early Career Award for scientists and engineers. Today, Professor Narayanan is here to talk with us about 5 flavors of misinformation about AI. He will be speaking for in the neighborhood of 40 minutes, give or take, and then we will have a Q&A. Please type your questions in the Q&A box. It should be at the bottom of the Zoom screen, and then we will turn to those at the conclusion of the talk. So Professor Narayanan, the floor is yours. Thank you.
Thank you so much for that kind introduction. Hi, everyone. I'm happy to be speaking to you today virtually, and I hope you can hear me okay. So the book AI Snake Oil is not about blanket technology skepticism. What we do in the book is try to tease apart which claims about AI are backed by evidence and which ones are overblown. So that's also going to be the theme of the talk today. I have 2 goals. The first is to dispel AI hype because there is a lot of it out there. But the second and perhaps more interesting one is to use AI as a case study to look at the complexity of the term misinformation, of the framing of misinformation. Because when I say 5 flavors, I'm going to start with claims that are straightforwardly easy to rebut, and then I'm going to keep going towards much more kind of epistemologically complex scenarios where it's not clear that the term misinformation is even the right way to think about things. And I think it exposes some deep questions about how do we get to the truth and what do we do if we can't? Okay. As a quick caveat, this is going to be an overview talk rather than going really deep into one topic. It's based on a bunch of papers we've written over the years. It's based on our book, and it's based on our newsletter as well. I'll be sharing citations throughout the talk, and I'm also happy to send along the slides later if you're interested in digging deeper into any one of them. The citations are going to be in the slides. So the talk today is about misinformation about AI, claims about AI, AI hype. But we've also written about kind of the complementary topic. What does AI mean for misinformation? And our perspective here, and that's not what the talk is about, but just in a sentence, our perspective here is that misinformation is not an AI problem. AI is not really a step change for mis and disinformation actors. And we have an essay on that topic. We're coming out with new writings on that as well. So in case you're interested in checking that out. Okay, so in our research for the book, the number one point of confusion that we noticed that came up over and over arises from the fact that when we say AI, when we say artificial intelligence, it's an umbrella term for a set of loosely related technologies. It's not one technology. Now, on the left here is ChatGPT. I don't need to tell you what it is. And on the right is banks might say they're using AI in order to predict how much of a credit risk somebody is. Right. So there's a reason these are both called AI. They're both examples of learning from data, but the similarities are superficial in terms of what data is being used, what application it's being used for, what the risks are, what the guardrails need to be. These are very, very different from each other. So ChatGPT is an example of generative AI, and I'm going to have a lot to say about that. But let's quickly talk about the example on the right, which is a type of predictive AI. Now, while generative AI gets all the press attention, when we look at what type of AI is really making an impact on people's lives, especially marginalized people, it tends to be by and large predictive AI. And what we're talking about is a typical example is criminal risk prediction, or the example I showed in the slide earlier of banks approving or rejecting a loan based on an automated prediction of whether or not the person is going to pay back the loan. It's also used in hiring, in education, in medicine, in insurance, and an ever increasing number of areas. And it's used to make really consequential decisions about people. And those decisions are based on a prediction of what the person will do in the future or what will happen to them in the future. In the criminal justice system, it is, will this person commit a crime when a defendant has been arrested? Their trial might be months or years away. Should they be detained during that time or should they be free? Enormously consequential decision. And the logic is based on an algorithm, a machine learning system, looking at patterns in past data to make a prediction of, is this person dangerous? Or are they going to commit another crime if they are free before their trial? So that's an example of how you can see it's really consequential, but also in the medical system, it can have life and death implications and so forth. Now, we think there are a lot of overhyped claims around predictive AI, and fundamentally, that's just because it's hard to predict the future. It's hard to predict who's going to commit a crime or who is going to be good at a job. And so, what we can expect from these quote unquote AI systems is that they might be decent at picking up crude statistical patterns, but it's not a magic 8 ball. They can't see the future. And we know in general that the future is not predictable, but somehow there is a collective suspension of common sense when the term AI seems to be used. And that's a big part of what we push back against in the book. And we question the extent to which we should be using these predictive AI systems at all. And I think the vendors of predictive AI systems are, to a large extent, aware of the confusion between these different types of AI, between predictive AI and generative AI, for instance, which has been making rapid progress, and it's remarkable progress, even though there are limitations that I will talk about. And I think many of these companies are exploiting the public confusion around what AI is to slap the AI label onto whatever it is they're selling in order to essentially present a claim to legitimacy, to accuracy, to perhaps superhuman ability, and as an implicit reason why we should trust these technologies to make these consequential decisions about us. So right off the bat, I wanted to say that sort of claim is something we should be very, very wary of. Okay, so generative AI, I don't need to define what it is, but for much of the rest of the talk, I'm going to talk about its limitations. In the book, we also talk about a few other major applications, the algorithms that are behind our feeds on social media platforms, a little bit about self-driving cars, etc. Okay, so that's kind of the first flavor of misinformation, definitional confusion, if you will. And as part of that, I'll say there are also some category errors that seem to be prevalent. And my favorite example of this is a person in Wyoming, apparently, who in the recent election cycle wanted a chatbot to run for mayor, wanted an AI mayor for the city. It seems to be just ChatGPT behind the scenes, but he calls it VIC for Virtual Integrated Citizen, which certainly sounds more sophisticated. Now, he claims that the bot has an accuracy an IQ of 155, and that it's going to make more accurate decisions than human mayors, and of course is going to be much more efficient. And the press I took this idea seriously, and the Washington Post, for instance, reached out to me to ask what I thought of were the risks of having an AI mayor. And I was just very confused by that question. I didn't know how to respond to that. I said, what do you mean the risks of having an AI mayor? It's kind of like uh, having a cardboard cutout of a car and asking what are the risks of that? I mean, it might look like a car, but the risk is just that you don't have a car anymore. As soon as I said that, it was a little snarky and I regretted it, but the Washington Post printed it anyway. And so after that came out, I started thinking about, okay, exactly why is it that I think there is a kind of category error here? Why does this not even make sense to me to be asking about the risks of an AI mayor? And what I think is the answer is if we think about why we have government, I think this suggestion fundamentally misses the point of that. The person who is advocating for this is really upset about the fact that politics can be really contentious, can consume a lot of time. But the reason for that is that politics is the venue we have chosen in our society to resolve our deepest differences, right? So that contention is the whole point. And imagine any contentious topic. This person himself gave an example of book bans as something he wants to delegate to ChatGPT. So let's say that ChatGPT was the mayor in your town and it made a decision on book bans that is contrary to whatever it is that you believe should happen with book bans. Would you accept that decision just because it came from an unbiased bot? I would say almost certainly not. And what that example shows is that accuracy is an irrelevant criterion, right? So to try to automate governance is to entirely miss the point. So these questions about accuracy and efficiency that are often ascribed to these AI systems as reasons for deploying them are often category errors. So that's the first big category, pardon me, first big flavor of misinformation I wanted to give you. These kinds of claims are very frequent, and hopefully it's, I don't know. I think it's not too hard to push back on them once you explain these issues to people. They do tend to get it. And I have to say, on a personal historical note, 5 years ago, the whole reason I started looking into what we've now been calling AI snake oil is because of one of these types of claims, and this is a hiring automation system. And these are vendors, AI vendors, who are going to HR departments and saying, "Look, you're getting hundreds, maybe 1,000 applications for each open position, right? You can't possibly go through each of them. So just use our AI system. Ask each of your candidates to upload a video, a short video of themselves talking about not even their job qualifications, but their hobbies or whatever it may be. And our AI is going to analyze that video and produce a report like this. So this is from an actual promotional brochure of an actual product. And you can see here it has rated this candidate on 5 different dimensions. That's just on openness. And then there's 5 more of these tabs here. And it's given this score that has 2 digits of precision. That's how you know it's supposed to be really, really accurate. When I look at this, there is no known mechanism by which something like this can work. We think this is just an elaborate random number generator. And 5 years later, despite a lot of criticism of these systems, there has not been a single peer-reviewed study. Forget about peer-reviewed studies, not a single opportunity for anyone on the outside, as far as I know, to examine the accuracy of any of these systems. So my position remains that there is absolutely no evidence that something like this can work. But I think the reason that they often manage to get people to at least suspend disbelief long enough to think that this could work is people don't think about the difference between generative AI, which is about, generating text or images or something like that, where there's a lot of kind of ground truth data, if you will, and you can train these systems to become more accurate at doing this. And something like this kind of personality assessment or predicting who is going to be good at a job where there is not that kind of objective ground truth. And again, it's hard to predict the future, as I was saying before, and there is a strong performance ceiling to any of these applications. And it doesn't matter that generative AI and foundation models are getting a lot better. When we look at predictive tasks, the accuracy has not really gone up in decades, basically. So these kinds of outright false claims are not limited to predictive AI. They're also present in generative AI. And a good example of this is this company called Do Not Pay, which claimed to have built a robot lawyer. And this is from a Federal Trade Commission settlement with this company that happened just a month or two ago, I think, which I was very happy about. So they are enforcing our laws against, our consumer protection laws against misleading advertising. This company had claimed that if any lawyer were to wear an earpiece and go to the Supreme Court and argue their case in front of the Supreme Court using their robot lawyer in their ear, they would pay them $1 million as an incentive. And it's just so silly. First of all, electronic devices are not even allowed in the Supreme Court. This was always just a publicity stunt just to begin with. But also there was no robot lawyer. But I think the fact that this was, again, at least believable enough to a lot of people that this got a tremendous amount of attention really shows that there is so much confusion about what it is that AI can and cannot do. Why did people even think it's possible that a robot lawyer existed? I've been thinking a lot about that, and I'll share some thoughts on that. By the way, there's lots of great screenshots from the FTC settlement, fake quotes, various other things. I will skip that part. But yeah, so this is the second big flavor. There are a lot of claims being made that are not backed by evidence. Again, it's easy to say, where's the evidence? And you can rebut those claims. But I think the more interesting question is, why are those claims believable in the first place? And so let's talk about that for a second. So specifically in the case of the robot lawyer, I think a lot of the confusion arose from the fact that OpenAI announced that ChatGPT, the GPT-4 version, was able to pass the bar exam, but also the medical licensing exam and other professional licensing exams with very high scores. There's some quibbling about whether this was actually in the 90th percentile or not, but to me, that's not the relevant part. Let's assume that it does really well on the bar exam. So does that mean that AI can do the job of a lawyer? When we look at lawyers actually trying to use AI, I think a very different picture emerges. This was one of the first attempts that was reported in the press to get AI to craft legal arguments. It went really terribly. And there have been a long series of instances of lawyers relying on AI to write these reports, not recognizing that chatbots tend to quote unquote hallucinate, make up facts, or even make up entire citations to non-existent cases, and submitting those reports without realizing the problem and getting into trouble with judges. Early on, when this used to happen, it used to make the news. Everyone was like, haha, how could they not know that chatbots can hallucinate? Now it's become so common that it's not even in the, doesn't even make the news anymore. And it's really sad, I think, that there are so many professionals out there who are still not aware that chatbots can hallucinate and are facing many negative consequences in their jobs because of over-reliance on these unreliable tools. By the way, this was one from just yesterday, and this was supposedly an expert on misinformation who was, again, using AI to submit an expert report, and it had fake citations created by these unreliable chatbots. Okay, so why is there this gap? Why is it that ChatGPT passing the bar exam doesn't mean much, doesn't actually make it useful for lawyers in the real world? So first of all, the reason that AI companies are even using these professional licensing exams to benchmark AI progress is not necessarily because they want to mislead, but because when you want to compare two AI models, right, how much better is GPT-4 than GPT 3.5? This is a decent way to do it when you're looking at those relative performance improvements. However, it doesn't tell you much about whether the model or the system is going to be useful in the real world. And there are two big problems, two big reasons why. One is that it turns out that things like the bar exam, so many of those questions are online. And so a lot of those answers might have been memorized by these chatbots when they're being trained on essentially all text on the internet. And even if a specific question that it's being tested on was not present in the training data, a very similar question might be, And it might be relying on kind of pattern matching to a much greater extent than a person would. And more importantly, a lawyer's job isn't to answer bar exam questions. And so we have a paper, the citation is at the bottom here, Promises and Pitfalls of AI for Legal Applications, where we distinguish between these more kind of mechanistic questions where there are right and wrong answers, things like question answering or things like transcribing text or translating between languages. Those are things that lawyers can use AI for. It can be a very useful tool, but that's not the hard part of being a lawyer. Those are all questions that are mostly handled by paralegals anyway. And AI does well at those questions because there are objective right and wrong answers. But for the parts requiring more creativity and judgment, it's not really possible to train AI in the same way, against a set of correct answers. And so, first of all, AI is not as good at that, but also it's much harder to evaluate how much better AI is getting. So when you take those evaluations on questions with objectively correct answers and extrapolate that and assume that AI is also getting better at questions that involve, matters of judgment, it ends up with a very, very misleading picture. So that's another kind of flavor of misinformation, if you will. And I think this hype about capabilities has also been augmented by hype about how rapidly AI is being adopted by professionals. As just one example, there was this paper making the rounds just a couple of months ago. I think this is a good paper, actually. People who do this kind of research tell me that the methods in this paper are quite good. So you can see here the title is The Rapid Adoption of Generative AI. Okay, so the title already makes a claim that this adoption is happening rapidly, but rapid compared to what? So let's put a pin on that and come back to it. And the important claim here that got a lot of media attention is that about 40% of people in the US are already using generative AI. And that does seem like a very impressive number, given that it's been only 2 years since the release of the first kind of mass market product, ChatGPT. This, again, seems extremely impressive. And they compare it to historical data, specifically the adoption of the PC a few decades ago, and they claim that AI adoption has been faster than this. However, what the abstract doesn't emphasize, but is mentioned in the body of the paper, is what happens when we consider what is called the intensity of adoption. In other words, when we say that someone is using generative AI, are they using it like once a week, or are they using it as a constant part of doing their jobs? Those are very different scenarios. Right. So it turns out that most of these users of generative AI are occasionally kind of perhaps casually, we don't know, but in terms of frequency, very infrequently using it. And you can extrapolate it a little bit based on, the average amount of time that people are using generative AI. And if you go back to PC adoption, we don't know how many hours per week a typical PC user was using it. But in the early days of the PC, if someone has spent several $1,000s to acquire one, my guess is that it's almost certainly not that they're using it once or twice a week. It's kind of a constant part of their jobs. And so if you imagine that someone is using a PC, 5 to 10 hours a week, for instance, and if you look at this paper's data on how much people are using generative AI, my assessment is that the adoption of PCs was a whole order of magnitude faster than the adoption of generative AI. And so it's an entirely different picture that emerges. And in general, I'm just very skeptical about this narrative of really fast AI adoption and kind of overnight transformation of the economy and of society. It might feel like that when we're in that moment in time and we're inundated with these press headlines. But if we take a sober look at the data, again, my assessment, people can reasonably disagree on this, is that this is not in any way a unique technology compared to other past technologies in terms of the rate of adoption. And personally, I also think the rate of innovation, we have a different paper on that, but let's put that aside for the moment. And so considering all this, that AI is nowhere near doing a lawyer's job, and it's not actually being adopted that quickly in the workplace. We think that fears of mass job displacement are totally overblown. There are definitely specific occupations like translation or stock photography, a few others where it has already had enormous impacts. But if you look across the economy, that's not the story we're seeing. And there's a very simple reason for this. Economists will tell you that jobs are bundles of tasks. A typical job might have like 20 different tasks that a worker needs to perform. And AI kind of has what's sometimes called a jagged frontier. So it might be getting really good at certain tasks, but not at all getting better at other tasks. So for any given job, the chance that AI is able to automate all 20 of those tasks is very, very low. And if it's automating some tasks but not others, what's going to happen is that that job is just going to get redefined so that the automatable tasks get automated and the person's job responsibilities focus more on the tasks that can't yet get automated. So that's the third big category. There's a lot of hype based on misleading evaluations. The science of evaluation is really, really hard, and we think that the AI community has not focused enough on that. And the existing evaluations are systematically biased in a way that seems that makes AI seem to be progressing and being adopted a lot faster than it actually is. And this misleading evaluation is particularly bad, we think, with so-called AI agents. Many companies want to build the agent from the movie Her, which is an assistant that you can give voice commands to, and it will carry out pretty sophisticated tasks on your behalf. Whereas when you look at the AI agent products that have actually been released, and when independent reviewers have tried using them, it's been a disaster. There have been some very notable product failures recently. And the kinds of failures, too, are pretty comical. So here's one of those products. It turns out that this assistant device incorrectly delivered DoorDash to the wrong address. And this is something we call the capability reliability gap with AI agents. If these AI agents could reliably do on our behalf everything that they're capable of accomplishing with some non-zero probability, it would be something truly spectacular. I think we would be using these agents every day. But if there is even a 10% probability of failure, it's a very different thing. We've had these with traditional assistants like Siri as well. I mean, if Siri plays the wrong song 10% of the time, for instance, that's an annoyance. But if one of these newer assistants is going to order your products to the wrong address 10% of the time, that's a product that's dead on arrival. Right. So that's kind of the state we're in now. And I think that gives you a sense of why a lot of the hype about AI agents in particular is just not based in reality or is based in really flawed evaluations. And there is also a lot of hype about automating science. There was a claim from this group called Sakana AI. But again, as you see on the top, when independent reviewers have analyzed these claims, it turns out that these are all way overblown. We have a couple of papers on this. One is called AI Agents That Matter. That's just broadly trying to advance the science of AI agent evaluation. The second one is specifically about AI agents, not for automating science, which we think is kind of a pipe dream at this point, but building tools for helping scientists do their job better. And even there, for even building relatively modest tools, what our paper has found is that these AI agents are not able to do that well right now, although this could improve in the next few years, and we're cautiously optimistic that it will. Okay, so regardless of our skepticism here, it is true that AI is being adopted exponentially across so many different scientific fields. I mean, the number of papers that engage with AI in some way has increased by an order of magnitude within just a 2-year period. And these graphs actually cut off before ChatGPT, so it's probably increased by a further order of magnitude, perhaps, in many of these fields since then. However, we think that this rapid adoption is not without problems. And in particular, we have been investigating one type of error that seems to recur across many of these scientific fields when they are starting to use AI as a tool or a modeling technique. And to illustrate that, let me give you an example from the use of AI in medicine. Epic is a healthcare technology company, and they built a machine learning model to detect sepsis among hospitalized patients. This is really important. Sepsis is hard to detect and it can be fatal. And if you can detect sepsis early, you can intervene with antibiotics and you can really save lives. This model was claimed to be really accurate, and on the basis of that, it was deployed in hundreds of hospitals, but it had not been evaluated independently. Although I'm told that Epic actually encouraged hospitals to evaluate it for themselves, but not a lot of hospitals had the resources. So the first independent peer-reviewed study, at least, was published in 2021. You can see the citation at the bottom. And what it showed is that the tool was not nearly as accurate as claimed. So here's a picture. And the accuracy measure here is AUC. It's called area under the curve. It's a way to measure the accuracy of binary classifiers. So 50% is random guessing. And Epic had claimed that it was between 76 and 83%. Whereas what the independent researchers found is that it was only 63%, which is barely better than a coin flip and somewhere between half and one third of how accurate Epic had claimed it to be. And beyond these numbers, it turned out that it was actually overwhelming physicians with false alerts and still missing the majority of sepsis cases. And to its credit, when this came out, Epic looked at the numbers and said to the hospitals, look, don't use our one size fits all tool. You can take our machine learning model, but you have to train it with the data in your own hospital. And that will help you ensure that you can test how well it's working for your particular patient population, which we think is absolutely the right approach. But how did this go wrong in the first place? How did Epic essentially fool themselves into thinking that their model was really accurate? It turned out that one of the features that this machine learning model was looking at was whether antibiotics had been prescribed for treating sepsis, right? So the model is essentially using data from the future, if you will, information that will not be available when the model is actually being asked to make a prediction in a hospital setting, and therefore a lot of these predictions are useless. They only work after the physician has actually already diagnosed sepsis and put that into the medical chart. And there are some news articles about this. But the point I want to make is that this is a very prevalent kind of error. It's an error called leakage. And leakage, it's a bit of a technical slide. It's a spurious relationship between the independent variables, which is the features that the model is using to predict some outcome, and the target variable, which is the outcome being predicted. And it happens because something went wrong in your data collection or sampling or pre-processing. Once you see that the model is using antibiotics as a feature, it's obvious to spot it. But when there are thousands of different features, it's hard to automatically figure out that one of these features is something that shouldn't be used when building the model. Okay, so this was an example of a deployed machine learning system. But it turns out that the very same error also pervasively affects the research on machine learning based science. And there have been, I'm going to show you a table here. It's going to look really busy, but I'll go through it and explain what I mean. So every row here is a systematic review of a particular field. So the way to read this is if you look at clinical epidemiology, for instance, this paper reviewed 71 papers systematically and found that 48 of them suffered from the pitfall of leakage. And in satellite imaging, it was 17 out of 17 papers, etc. So, and we've been compiling this. People who are doing this in different fields don't necessarily recognize that the error they're talking about has a name. It's well understood. It's called leakage, and that people in all these other fields are also finding the same thing. And this table has grown quite a bit since we first compiled it. The full version is on our website, and we have a couple of papers about this as well. And we're calling this a reproducibility crisis. I know that's fighting words, but if you read our papers, hopefully you'll be convinced that in a lot of these fields, the majority of papers are probably making claims that do not stand up to scrutiny, that are not reproducible claims. And we kind of did a deep dive into this in one particular field, in the field of Civil War prediction. There had been a series of papers in Civil War prediction starting in 2016 that claimed that you could use machine learning or AI or whatever you want to call it to highly accurately forecast which countries in which years are going to have a civil war breaking out. And here's an example of one of these papers. So on the left here are the numbers that they claimed. The dots at the bottom are kind of traditional, what are called logistic regression machine learning techniques. These are decades old statistical techniques. And the paper said by using more advanced random forest, which is also a kind of old technique at this point, you can get much better accuracy of something like 95%. But of course, we found that these results are affected by leakage. When you correct leakage, you see the dots at the bottom. Not only is civil war not very predictable, as you should expect, you just can't predict the future no matter what field you're talking about. So this is only slightly better than random. Again, 50% is a coin toss. These newfangled random forests techniques are not really better than traditional statistical techniques. And we found this over and over in all of these papers that claimed that these newer AI methods were better and could predict civil war accurately. It was the same thing. They were all affected by leakage. And I'm not going to use the term misinformation to refer to this, but this is the fourth flavor of misleading claims about AI. And you can start to see here that this is starting to get much more complicated. It's not the case of a company trying to fool people into buying its product. It's obviously people kind of fooling themselves, not fooling others. There's no malice involved in any of these cases of irreproducibility, as far as we know. And even the fooling oneself is in some cases because people are being careless, but in a lot of other cases just because it's just really hard. And the end result, though, is the same. You have this enormous pile of papers that are all seeming to say that AI is leading to breakthroughs in a variety of different scientific fields, but in most of these cases, they suffer from one of many pitfalls. Only one of them is leakage. There's a whole bunch of other ones. But the other reason this is interesting is that when we pointed out that the papers we pointed out were committing like really basic machine learning 101 errors. These were not examples of subtle errors. There are some subtle errors, but that was not the case here. Their response from the political scientists was really interesting. They said, "Oh no, this is just a different research practice in our field. It's train test split is one of the terms that's used for this. If folks are familiar with that." And they said this is I'm simplifying a little bit, but that's not really important in the way we do statistical models in political science. And from their perspective, it was not an error at all. And that was really shocking to us. And when we talk about this at machine learning conferences, people's jaws just drop to the floor. And it's really hard to understand what's going on. How can a machine learning 101 error that leads to what we consider to be these clearly very erroneous, very exaggerated claims be defended as acceptable scientific practice in another discipline? So as I started thinking about this, I realized that the situation was more complex than I had given it credit for. I do still think this is very much an error and those results are all mistaken. But what I realized is that it's up to us to make the case for why it's an error. It's not enough to point to those machine learning textbooks. And the line between error and reasonable methodological disagreement is not at all clear. And this is why, I'm certainly not going to use the term misinformation, but even using the term error here is a little bit of a normative judgment. Now, I will defend my decision to use that term, but it's not an uncontroversial or a straightforward decision. So there's no universal criterion. I mean, and I think to philosophers of science, this must be very well known. But in particular, for these statistical models, there's a famous maxim that all models are wrong, but some models are useful. Any statistical model of the world that you build is going to leave out some aspects of the world and incorporate other aspects of the world. So in some sense, it's always going to be wrong. So the question is not whether the model is right or wrong, but whether the model is useful and whether the model is so far from useful that we should consider certain modeling choices as an error and not accept papers who commit those types of modeling choices, for instance. And that's ultimately a sociological determination. A community must come together and, based on various criteria, which cannot always be logically defended, agree that these are acceptable modeling choices and these are erroneous modeling choices. And again, we think there is no place for leakage here, but that is ultimately a matter of kind of social consensus in various scientific communities as opposed to an incontrovertible truth. And so this was a bit of an unsettling experience for me, how something that's a well-known error in one field can be still a matter of debate in another field. But I'm glad I had this experience because when I started working in AI safety, I saw how things can be much, much murkier than even the situation that I had talked about so far. Because it turns out that on the question of whether advanced AI can be an existential risk, there are kind of bifurcated realities that have emerged between different camps who have very different worldviews, and the debate is very, very polarized. And so one group thinks that this is no one is claiming that current AI can cause human extinction. But one group thinks that this is an urgent risk with future AI that requires dramatic policy interventions at this time. And another group, and I'm in the latter camp, thinks that we're nowhere near the threshold of evidence to make any such determinations. And the key thing is that both of these groups consider the other group's policy prescriptions to be really dangerous and will kind of make things a lot worse. And so this is a debate that kind of really matters from a policy perspective, as opposed to a lot of scientific debates where it's okay if people are fighting each other for several decades and then gradually some truth emerges, right? So we can't wait around for existential risks to materialize. If we do think they can materialize in the future, we need to act now, and we need to act with imperfect evidence. But exactly how imperfect can that evidence be? And so this is a question that does require an urgent policy debate, even if people like me think it doesn't require major interventions at this time. And that debate needs to happen without the luxury of the usual kind of the luxury of time that we have in other areas of science. And I have a lot to say about this, but I want to leave enough time for Q&A, so I will just very briefly mention a couple of last points. The reason there are these bifurcated realities is that the worldviews are different. The set of assumptions that people bring into it, assumptions that are not easily empirically testable, even the vocabulary that people use to talk about these risks kind of commits one to a particular way of thinking about what the future trajectory of AI is going to be. People differ in how they interpret the existing evidence. For instance, is AI adoption happening rapidly? Is it more rapid than previous technologies? I showed you how I interpret the evidence differently. And of course, that leads to different expectations about the future. People use different epistemic tools to even make sense of the situation. So in the AI safety community, which considers the risks to be urgent, there's a big focus on probability estimation. What is the probability of AI extinction in the next 50 years or something like that? Whereas we have an essay arguing that these probability estimates are too unreliable to be meaningful at all in a policy context and should basically be ignored by policymakers. So again, if you have different epistemic tools, it's going to lead to different beliefs. And if you have different values, it's going to lead to different prescriptions about how to weigh risk and what to do about those risks. And so this has been really humbling. Both sides are accusing each other of misinformation. In some cases, the debate has often gotten very heated. Obviously, I don't think that's a good way to go. I do think that the camp that I disagree with also has a coherent worldview, and I hope they will give me the same benefit of the doubt. And it's been hard to know how to make progress in the presence of these kinds of bifurcated realities. And the conclusions we've come to, by the way, we have a paper on this coming out hopefully in a week or two called AI as Normal Technology, where we explain our worldview, not trying to change anybody's mind, but to put these stakes on the table as a starting point for some constructive debate. The two things I think that I've learned in this is that the most important thing for this debate is to get the social preconditions right. If people aren't talking to each other from a position of mutual trust, which unfortunately is currently scarce in this debate, it's not going to lead to progress. And in online settings, in papers and blogs and social media, it's very hard to build the sense of mutual trust. I think it has to happen to a large extent in kind of more intimate, closed door settings where people actually get to know each other before they start trying to debate this issue. And even when they do, what we can hope for is not going to be convergence of beliefs, but I think there can be mutual understanding. And I do think there can be a lot of policy agreement without even having convergence of beliefs on how serious these risks are and what timeline we're looking at. So again, it's been very humbling to be in this field where it's not even clear how to access any notion of truth around which there can be consensus. And it's also been high stakes because policymakers all around the world really want to know what approach they should take to thinking about these risks. And I very much welcome your thoughts on this. So to summarize, these are the 5 flavors of quote unquote misinformation. It starts from straightforward cases of things that I think are just confused or incorrect, and then it gets to things where the misinformation label really doesn't make sense, and we really need to have a conversation about epistemology and kind of philosophy of science and those kinds of deep questions, while also facing the urgency of the policy debates. Okay, I hope you found this interesting, and I look forward to hearing your questions. Thank you so much.
Thank you so much for that. Fascinating. I just want to mention one more time, if you have any questions, please put them in the Q&A box rather than in the chat, and we're going to work through some of them. If somebody's asked multiple questions, I'm going to sort of go through everybody who's in there at least once and then sort of circle back. So apologies if I'm not necessarily going exactly in the order in which they appear. So the first question, since AI is a black box of sorts, how can a user gain insight on how the AI was trained or programmed in order to best meet the task requirements for the application we want?
Definitely. Yeah, AI is a black box in the sense that if you look at a giant neural network, we can't necessarily explain what each individual neuron does. However, that kind of explanation is not really necessary for the vast majority of things that end users ultimately care about. We have really good ways now to audit AI. We can get statistical guarantees on how it's going to behave in any particular scenario. And we can ask for data from AI companies about how the system was trained and so forth. The bigger problem is the lack of transparency from many AI companies on those kinds of evaluations that they have internally, but have not produced for the public or for end users to examine. And it's less of a problem of opening the black box of the model, and it's more of a problem of opening the black box of the proprietary claims of companies and their refusal to release data in many cases.
Okay, next question. How can we be smarter about using AI in work and daily life since it's here to stay?
For sure. Yeah. One thing I would say is that generative AI, unlike a lot of other technologies, unlike previous AI technologies that are used by companies and businesses, is just remarkably accessible to, everyday individuals. And I think spending a few hours trying to use these in your own workflows is going to give you a much better idea of their strengths and limitations than, reading papers about it or listening to talks about it or anything else that doesn't involve direct interaction with these tools. There are various other suggestions I can give, but the number one thing is just to play with these tools and make decisions for yourself.
Okay, next question. What are your thoughts on using LLMs as evaluators, for example, in assessing candidates for hiring or student work? What considerations are necessary to make sure that these model outputs are reasonably useful, fair, and accurate?
Yeah, there are many ways in which you can try to use LLMs for evaluation of job candidates, for instance. Maybe you're using it to extract information from an essay they have written and put it into a structured form that you can search on and look for candidates who have particular kinds of experience and so forth. So those, I think, are perhaps more defensible ways of using LLMs in this kind of high consequence task. Although even here, I would be extremely cautious. But the more black box kind of way of using things, where you just put an applicant's information into a chatbot and ask it to spit out an evaluation, I think, frankly, that is a completely ethically irresponsible way of doing things. There is no technical or moral case to be made that that can lead to better evaluations than doing the hard work of, human evaluation of these applications. I understand the impetus for doing this. How are you going to rate 1,000 different applications? It is a hard problem. There are no easy answers. We talk about this in our book of how broken AI tools are often very appealing when there is something broken in the organization or institution itself, and AI seems really appealing as a quick fix. But I would very much encourage great caution when using it for candidate evaluation or evaluation of student work. My one sentence answer to it would be, don't do it.
Okay. Next question. Is it possible to create a medical AI program that works but without bias and discrimination? The answer to me seems no. See the work of Dr. Anthony Sully at Harvard Medical School. Please comment on the situation.
Sure. It depends on what you mean by bias and discrimination. There are certain kinds of biases that arise because, let's say, your training data was biased, for instance, and you can hope to collect better data, correct the biases in the training data, and yeah, in some cases there can be technical fixes. Or let's say there's a medical application where you can take a picture of a skin lesion with your cell phone and it tries to classify whether it's cancerous or not. And these types of things famously work poorer on pictures of darker skinned people. And these are things where you can try to have technical fixes, and there has been a lot of progress in doing so. There are harder cases of bias. A well-known example is a paper by Ziad Obermeyer and colleagues, who looked at the fact that a uh, a predictive model that it was being used by many hospitals was heavily biased against Black patients. The reason being that the model was being trained to predict cost and try to predict which patients will incur the greatest cost for the hospital or the insurer in the future, and minimize cost by targeting interventions for those patients. And since historically hospitals have spent a lot more on white patients, the tool, of course, faithfully picks up that bias and reproduces that bias. Now, if we want to fix it, we can fix it relatively easily by retraining the model to predict, instead of who's most costly, who is the sickest and in most need of intervention. I think that's great. We should absolutely do that. The reason this is hard, though, is because the hospital has to accept that it is no longer going to be minimizing cost. The reason that discrimination was so attractive to the vendor and to the hospitals in the first place is that they were trying to minimize cost. And so when you're advocating for removing this type of discrimination, which of course we absolutely should, it's not purely a technical problem. It's also a matter of convincing the decision maker in charge that they should incur some cost, if you will, in order to do the ethically right thing.
Okay, next question. Can you define normal technology briefly?
Sure. Uh, I think yeah, I'm happy to send along a draft of the paper. It's going to be hard to give a one sentence description, but I'll try. The distinction is about whether we should treat AI as similar to previous technologies that are tools, things that we can control without having any dramatic policy or technical interventions, or whether we should treat it as something potentially human-like that is going to be fundamentally challenging to control and therefore necessitates, again, perhaps dramatic policy interventions in order to ensure that super intelligent AI doesn't pose any risks to humanity. And we think that the control problem is not nearly as hard as has been portrayed by people who are raising the alarm, and it is going to continue to behave much more similar to normal technology than to a human-like entity.
All right. Where can we go to hear and or get involved in some of these policy debates you mentioned?
Yeah, AI policy is a very active topic. One suggestion I will give is that it's a lot easier to do it as part of a group than as an individual. So, for instance, we are an academic unit who has a lot of infrastructure, connections to federal, state, and other policymakers and so forth. And so you kind of need that infrastructure, I think, to kind of put the wind in your sails. And so that would be the number one suggestion I would give, right? So don't do it as an individual, do it as part of an organization that has a strength in technology policy.
Okay. Um, Even if the crowd that wants to regulate slash address AI as an extinction risk or existential threat arrives at the capability or political will to regulate, what does such regulation look like in practical terms? Censorship? Shutting down companies developing AI? Isn't the toothpaste already out of the tube?
Right. So that's been a big part of why this debate has been so contentious. So in my view, actually risks can be minimized by ensuring that AI is widely available so that there's no concentration of power in the hands of a few companies or even countries. And putting the toothpaste back into the tube, if you will actually increase risks, even if it were possible. And of course, there's a group of people who has a very different view on things. But in terms of what kinds of policy interventions I would advocate for, there are many things we should be doing now that will be helpful regardless of what your views are on existential risks from superintelligence. One good example of this is that we think there is not nearly enough transparency from AI companies about what's going on the inside. And we need that whether you're worried about more kind of mundane risks, if you will, like people over relying on AI for, legal citations or whatever, or if you're worried about these super intelligence risks, we need a lot of the data that tech companies have on the inside in order to better anticipate and address these risks. And I do think AI is exceptional to some degree in one sense in that because of how big the stakes are for society, regardless of which risks you're concerned about, the usual deference that is given to companies' commercial proprietary interests should be weakened, and there should be regulation that compels companies to put a lot more information into the hands of the public than you would expect from companies in another sector, like, let's say, automobiles.
Okay. One or two more. Please comment on the recent proper use of AI in the winning of a Nobel Prize in chemistry. What did these researchers do to ensure the proper and relevant use of AI as a tool?
I think it's really exciting that there is both AI that is being used for the sciences and ideas from physics, if I remember correctly, that was helpful in the development of hot field networks, which led to one of the Nobel Prizes. I think this interchange of ideas between AI, which has been generally a more engineering focused field, and sciences, which are about understanding and explaining the natural world, is very, very healthy. But like I said in my talk, there are huge pitfalls, the extent of which has not been widely recognized. And I do think things are going to get worse before they get better. There are so many other examples I could give you. There was a pair of widely publicized papers in Nature about automatically synthesizing various chemicals that was quickly debunked. Again, there are really at this point hundreds of examples. So I think we do need a very serious course correction to ensure that this hype train doesn't get out of control and we're actually producing knowledge as opposed to the illusion of knowledge by using AI to come up with findings that end up describing something about the model, but don't actually translate to knowledge about the world. So that gap has to be recognized and mitigated.
Okay, we've hit 3 o'clock. I was really hoping to get one or two of my questions in, but unfortunately, we're at the witching hour. So please, everybody, join me in thanking Professor Narayanan for a really fascinating presentation. That was terrific. Thank you very much.
Thank you, everyone. This has been a really fun discussion.